In today's lesson, we're going to go back over some trig word problems. And what makes this year a little bit different than the word problems from last year is sometimes you're going to have to draw our triangles and our dimensions in 3 dimensions. So a few terminology we need to review is the angle of elevation and or inclination. And so that means the angle is opening up. What's really important, and in your notes right now as you're working along here with the video, be sure that you have this word horizontal highlighted in both definitions. That's the part that's so important. So the angle of elevation comes off a horizontal, so it means it opens up. And the angle in here is what we're talking about, that angle there, theta. Now when we're talking about our angle of depression, it also has to come off a horizontal and it's going to open down. So sometimes if we're standing on a building, let's look over here, and it tells us that there's an angle of depression of 20 degrees. We have to be sure, first of all, that we have a horizontal line. So if we have someone standing up here that's looking at the ground at an angle of depression of 20 degrees, that 20 degrees goes here in our diagram. If we need to know what this angle is in here to help us out, then we know that we subtract the 20 from 90 for that one, which gives us 70 degrees. But the angle of depression to the line of sight looking down has to come off of the horizontal. If you were to put the 20 degrees in here, it would make errors all throughout your diagram because you put the angle 20 degrees off of a vertical line. It must come off of a horizontal. We can't stress that enough. So we're going to read through 3 word problems in this video, and I'll get you set up so you can get used to the diagrams. Then I'm going to ask that you do the calculator work and solving them on your own at home and bring them into class tomorrow. So let's look at question number 1. Move that out of the way for now. A surveyor must measure the height of a cliff. He stands 40 meters away from the base of the cliff. So we'll start to draw a cliff. And he's 40 meters away from the base of it. Now we're going to put vertical line down here at 90 degrees. So that there would be 40 meters. And the angle of elevation to the top of the cliff, so someone standing here looking up, our angle of elevation opens up, and that would be 60 degrees. So that's what we can find our height here. That's one of our straightforward diagrams that doesn't need 3 dimensions. Because there's a right angle in the triangle, be sure that you remember to use your trig ratios, SOHCAHTOA, as opposed to sine law and cosine law. So we need the opposite side, and we know the adjacent, so we're going to use tan to solve that. So tan 60 is opposite over adjacent. Tan 60 is h over 40. And then you can use your algebra and finish solving that question on your own. Let's look at example number 2 here. The surveyor must measure the height of a cliff, but there is a river between the surveyor and the cliff. The surveyor stands directly across from a rock at the base of the cliff and measures the angle of elevation to the top of the cliff to be 30 degrees. She then turns 90 degrees and walks 70 meters and measures the angle formed between the line of sight to the rock and the path back to her original position to be 65 degrees. So it's always good to go through the whole question like I did there and then go back and start to break it apart for the important parts. So what we have first of all is the surveyor stands across from a rock. So I'm going to put an R for rock, and there is a surveyor standing across from it. So I'll put an S there for the surveyor. He stands directly from a rock at the base of the cliff and measures the angle of elevation to the top of the cliff to be 30 degrees. So to the top of the cliff, all the way up to the top of the cliff there to be 30 degrees. She then turned 90 degrees and walks 70 meters away. So the surveyor then turns 90 degrees, and so you sort of have to think of this as three-dimensional. So she's now walking this way. She was facing this way. She then turns 90 degrees and starts to walk. She walks 70 meters away from her new line of sight to the path back to her original position to be 65 degrees. So then we have this line of sight here, and this in here is 65 degrees. How tall is the cliff? So picture this dotted line to be flat on the ground. And that might help you. So once you find RS, side length RS, using your 65, 70 meters and 90 degrees, then you'll have enough information in this triangle, let's call this A, to solve for the height of the cliff here. So sometimes you have to solve within a triangle that's not needed in order to solve for a measurement in a triangle that is needed. So I'm going to leave you with that to try and solve. Again, you have a 90-degree angle there, so trig ratios is going to be important. Our last question, a Coast Guard helicopter is flying at 1,200 meters and spots two sinking ships. We have the HMCS and HMCS Bertram. So I start right away. I'm going to put height. So height from the ground, draw height usually with a straight line. And there's a line of sight, okay, to the Stewie. Can even do that solid as well. And to the Bertram. So I have S here, line of sight to the Bertram there, 1,200 meters above the ground, and height always makes a 90-degree angle. So try to get a I'm going to make that just to extend that. A little bit of a three-dimensional perspective on that there. I'm going to clean that, just this part here up a bit. There. So that's to the 90-degree angles in here. Again, I'm just going to make the diagram just a little bit neater, so hopefully you can see it there. It takes a bit to get used to working with the sketches with the three-dimensional aspect to it. But once you do get it, you know, they're usually pretty consistent with the same triangle time and time again. So we'll put the helicopter up there. So now we have a diagram. Let's go back and read what other information we have. The angle of depression to the Stewie is 60. Now I remember that my angle of depression has to come off of a horizontal line. So I put in here, this is 60. So this angle in here that I actually need is 30 degrees. The angle of depression to the Bertram is 34. Angle of depression has to come off of a horizontal line. So what I actually need in there is 56 degrees. And now I have enough information that I can start to solve what I need. Find the distance between the two ships. So I'm looking for the length of SB. Again, sometimes you may need to solve for information you don't have to in order to be able to solve for what you need. So using my right angled triangles, I'm going to solve for this side using trig ratios. And then I'm going to solve for this side using trig ratios. And then down below, you now can solve for your triangle SB. I'm just going to reiterate too, if these sides don't help you, you can use trig ratios for these ones here as well. Okay, so I'll let you try to do the calculations with those. Bring in your work that you have to class, whether you think it's right or not. We're going to solve these three together in class to be sure everyone has the right answers, and then move on to you working and doing the diagrams on your own. The diagrams are the hardest part. Usually when you get that, the calculations are easy enough.